Now we continue with the next part in the model number 5, setting up the regression dataset and evaluation of the results. So firstly, you need to tune in your set for matching the available experimental data with the regression set. First, the component specification must be updated to reflect the results of the lifting calculation. This is done by selecting File, Update Component Properties from the main menu or clicking Update Component in the toolbar, which will modify the first 3 forms in the dataset. And after that, you click Yes when asked if you want to proceed. You need to open the title EOS unit from and enter the new command and the derivative title for this dataset. Besides that, on the component selection properties, from the property of the full component specification, including the heavy skilled component, can be viewed and a new command enter as shown below. This is the updated component after you perform the tuning process. The next step is you select the constant volume shift in the box. In the upper right is shown above, and click Apply Change, then Cell, then go to File Cell. You need to open the composition form to verify that the mole fraction now to sum to 1. And as shown below, all of the mole fraction for your all of the components need to sum to 1. Okay, you should be careful about it for update composition. And now the next point is the lifting calculation can be removed from the dataset by right-clicking to the blood fracting lifting in the tree view. Then you selecting cut. If you want to avoid overwriting the original dataset, you need to select File Cell A and enter a new name for the dataset, whatever the name you would like to put. Okay, and then you begin to set up the regression run. You list composition in the tree view and list regression parameters or select drug variation entire regression from the toolbar. The regression parameter ran often in the tree view below, and this interface will present for you the regression parameter selection to be performed for BVT matching for condensate model. Regarding the saturation ratio, the constant composition expansion, and the constant volume deletion, the specification experimental data can now copy from your data file condensate data. You open this file and you copy up 3 data items and paste into reference log in case study number 1 data. This is the case study we perform for the model. And how to do so? You need to right-click on the condensate 3 node and then close this dataset. After you perform this step, the tree view should appear similar to the following photo. Okay. Regarding the regression parameter selection, the parameter now to be used for regression can be selecting by clicking regression parameter. Okay, and you can selecting the component property tab. At this tab, you select the critical ratio of C7 large scale components and regression variables by clicking on last 5 cells in the first column, label BC. And the component property tab should appear as shown below for your out simulation. The next important step is to select the interaction coefficients. You go to interaction coefficients tab and have and there here some hydrocarbon interaction coefficient abundant, so below. Okay. And the next we need to save the dataset a condensate regression data or whatever the name you would like to put here. Then after you save the dataset, you need to run the regression dataset by select the file run or click run simulation in this here. If you have not saved your data, a message box appears asking if you would like to save the dataset before running. And of course, you need to click yes to save your change, because it is very important for saving your time, just in case you make some error during the modify the dataset. While the dataset is running, the rosette operation can be tracked by noting value of the residual in window display in the run status message. This information is also entered to output file. It is important to note that the magnitude of the change from initial value of residual is more important than values of the residual themselves. It shows the summary lot of the before and regression and after regression result. You can view this graph by stop simulation result, simulation graph in the G view. Okay. It shows file matching between the simulation and the experimental data when you view from this photo. And the next step you can have a look and summarize plots for run so only minimal improvement in the fish were obtained, and particularly the Lewis dropout value for the constant volume deletion had a large error. You can have a look in this description. To check the numerical value for before and after regression calculation error, you open the output file through the simulation result. You go to simulation output in the G view, and probably you can have the interface like this. You can observe the difference between the before regression, after regression, and experimental data. In the same time, you can know the error after and before running the regression. And you can see the value of experimental data and after regression is low when you perform before regression. Okay, I think it is necessary to perform the regression for matching the simulation data and experimental data. And this slide is the final slide for the second part in the model number 5. You can actually show more information when you would like to load in the Excel file to compare in different simulation time. And we will meet again in the next session for model condensate model.